Hello and welcome. I am Tejas Almelkar, Director of Quality Assurance at Aris Global. In today's session, I will be discussing the importance of synthetic data generation in regulated domains, specifically in pharmacovigilance within the life sciences space. One of the major challenges in pharmacovigilance is the limited access to real world data due to stringent privacy regulations. This makes it difficult to develop and test safety systems in a compliant manner. This is where artificial intelligence offers a valuable solution by generating realistic and logically consistent synthetic data. In today's demonstration, I will showcase how ChatGPT can be used to generate data that is realistic and compliant without involving any real patient information. Post that, I will demo how synthetic data can be used to create E2B R2 XML suitable for use in safety systems. Before we proceed with actual demo, let us understand how synthetic data can be leveraged in pharmacovigilance. Let's look at some of the application of synthetic data in pharmacovigilance. First is training of machine learning models, and then it is testing of pharmacovigilance. Synthetic data enables scalable training of machine learning models. Some of the use cases are models for auto coding of meta terms, classifying seriousnesses, automated causality assessment. There are variety of models for data exploration and risk categorizations, for latency profiling, risk prediction, and pattern mining. Today, however, we will be focusing on leveraging synthetic data for PV system testing. Some of the real world scenarios for testing are testing of Medra autocoding and data population, data quality and consistency check, testing regulatory compliance like duplicate detection, and aggregate reporting and signal detection. In today's demo, we will focus on two key areas. First is data generation. We will create realistic and synthetic data using ChatGPT. And then we will create an R2 XML with the same data that was synthetically generated. Now I'm going to demo the actual process of generating synthetic data using AI. Let me start by opening the official ICH ICSR guideline document for R2 XML. This document defines the structure and expected content of safety reports and details on how the data elements are to be formatted. The data generated should be compliant to these guidelines. Next, I will use ChatGPT to generate synthetic data. I have pasted a prompt here with instructions to create data based on defined guidelines. In this particular prompt, I have asked GPT to create two sets of data, but obviously one can create hundreds of such data sets using AI. Now, let's look at the output. We see synthetic records here that include realistic patient data like patient date of birth, patient weight, patient height, gender, etc. Here we have patient medical history. In fact, this is what we call as repeatable blocks. So we have other set of patient medical history as well. We also see drug here, metamorphin in this case. The key strength of AI generated data is how it preserves logically grouped fields. For example, in this case, the drug name is metamorphin, and we have relevant indications and reported reactions. As we see here, usage of AI offers both efficacy and efficiency, enabling generation of structured and safe test data in minutes. Now that I have successfully created synthetic data, I am going to demo the generation of R2 XML using AI. I have a prompt ready for generating XML file. I will copy this synthetic data, paste it into the prompt, and now the complete prompt is ready. I will now use ChatGPT for XML data generation. This might take a couple of minutes, and once it is done, we will compare the synthetic data generated with the R2 data XML. So here we see patient information, the age, height, weight, etc. is consistent with what we had seen here. '72 and '68, the medical history, diabetes, corresponding text, the drug metamorphine, the indications. So as we see here, the data generated synthetically is now part of the R2 XML. One thing I wanted to highlight is that this is the single file that I have created for this demo. However, using advanced versions of AI, we can programmatically create hundreds of such XMLs, which then can be used for effective testing. As we have seen in today's demo, the generation of synthetic and regulation compliant data through AI opens new pathways for PV system testing. AI solutions can become instrumental in accelerating development and validation of safety solutions. So I thank you for being part of this demonstration today. In my next session, I will focus on application of AI in training machine learning models. Thank you.